There's a fair bit of terminology in gas switching, so in this video clip, I'd like to discuss some of those terms. I define the terms here on the left page and show typical time graphs for open flow and stop flow on the right page. So these are, for example, CO2 versus time in both plots. Channel. This is the same as chamber, and as discussed in an earlier video, chamber 1 is reserved for reference. Usually that means it's empty and used as a control, whereas chambers 2 to 8 can contain specimens. The sample time is the time between samples of the sensor voltages. This is determined in Logger Pro software. Its default is 5 seconds, but for short experiments you can sample faster than this. 5 seconds is sufficient to give you many hours of data collection. So it is the time between samples, shown here by the black dots. The dwell time is the time spent analyzing each chamber, and it's usually 4 to 5 minutes for a typical flow of 25 to 50 mils per minute and a chamber volume of several tens of mils. So this is the time spent analyzing a particular chamber. This is determined by the flow, the volume of the chamber. You have to give the dwell time enough time to include washout of the previous chamber's gases in the tubing, and also in the case of open flow to attain a steady state level from which you can get the open flow differential, the sample voltage minus the reference voltage, which is used in calculating VCO2. The event time is the time at the end of a dwell time. It's usually 15 to 20% of the dwell time. It's when the event average is calculated. So an event average is calculated for that chamber over the event time. So the event time is usually 30 seconds or of that order. The time data refers to data as a function of time for all sensors. So for example here, if this variable was CO2, then the plot here is the time data. Event data are the time plots of the event averages. So there are far fewer points in the event data than in the time data. Time data contains all the raw sample points. Mode. The software is capable of operating in 2 modes. In mode 0, the chamber sequence is 1, 2, 3, 4, 5, 6, 7, 8, and then repeats 1, 2, 3. In other words, it looks at a reference every 8th chamber. So it samples a reference every 8th chamber. This is most useful when you want a lot of measurements of a particular sample. Let's say, for example, chamber 2, you measure it every 8 samples. However, it has the fewest repeats of the reference. The reference also is every 8th chamber. So if there's a lot of drift in either the reference gas or in a sensor output, then this gives you the fewest measurements of the reference. In mode 1, the sequence is 1, 2, 1, 3, so forth until it repeats. In other words, the reference is measured every other chamber. So it's by far the best mode for tracking reference if there is a reference drift. However, you get fewer measurements of a particular sample. For example, chamber 2 doesn't appear again for 14 chambers. So you get far fewer measurements of a particular chamber. The cycle time is the time required to get repeats of a particular chamber. For example, in mode 0, you have to wait for 8 chambers before you come back to a particular sample. So therefore the dwell time is 8 times, so the cycle time is 8 times the dwell time, of the order of 40 minutes, if the dwell time is 4 to 5 minutes. In mode 1, you have to wait 14 chambers before you get back to a particular sample, so therefore the cycle time is 14 times the dwell time, slightly over an hour. In the open flow configuration, the data of interest that allows you to calculate VCO2, VO2 is the open flow differential. So this is a steady state value above the reference level. Whereas in the stop flow, the data of interest is the area of the peak when the bolus is washed through the analyzers after a certain period of stop time. Just as a point here, at the end of the dwell time in stop flow configuration, you actually do get the open flow differential, just as you do in the open flow. However, since you're usually using this configuration for small specimens, this open flow differential is too small to be useful. That's why we use the area, which is a much bigger signal and can be controlled by the length of time you leave the chamber stopped. The final term I would like to point out is the O2 delay. This is required to align the oxygen and carbon dioxide signals. And the reason for it is that the oxygen signal is slightly later than the CO2 signal, because both analyzers are in series with the O2 second. The way to make this alignment is to use peaks of the CO2 and O2 and line them up, or in the case of stop flow, or use transitions in the case of open flow to align a CO2 and an O2 transition. Default values are usually 2 to 6 sample times, and the software aligns or delays one signal with respect to the other 2 to 6 sample times. So this completes the discussion of the terms of switching.